I'm so glad you found your way here tonight. Your mind erases most of what you dream, forgetting elaborate stories, vivid images, entire worlds before you even open your eyes. Tonight, you'll discover why your sleeping brain actively chooses to forget and understand why this forgetting might be the most important work your mind does each night. Welcome to Sleepy Science Night. Wherever you are right now, perhaps wondering about dreams that slipped away this morning, or curious about the stories your mind tells while you sleep, allow yourself to settle into this quiet space. We'll journey through 100 psychology facts about why we forget our dreams. From the sleeping brain's memory systems shutting down, to neurons that actively erase dream content, to the protective wisdom of letting most dreams fade into darkness. This thoughtful journey through consciousness builds bridges between searching minds. A soft subscribe, like, or sharing your thoughts creates a pathway for more dream seekers to discover and brings us closer to protect this sanctuary. One sleepy soul at a time. Your journey inspires ours. Let yourself settle completely here. Feel your jaw unclench, your breath deepen naturally. You can let these thoughts drift past without holding them. Sense that soothing heaviness enveloping you, like your consciousness slowly dimming its brightness. Thoughts dissolving into peaceful fog of approaching sleep. Close your eyes and breathe deeply. You're floating where memories rest safely in gentle darkness. Let your mind merge with infinite peace. And now we begin. Most dreams vanish within 5 to 10 minutes of waking, disappearing so quickly that by the time you reach for your phone or turn on a light, the majority of dream content has already dissolved. Research from sleep laboratories consistently shows that approximately 95% of dream content is forgotten within those first crucial minutes after opening your eyes. This rapid forgetting happens because your brain treats dreams fundamentally differently than waking memories. During sleep, your hippocampus, the seahorse-shaped structure deep in your brain that normally stamps experiences into long-term storage, operates in a completely different mode. Instead of encoding new memories for permanent keeping, it's busy replaying and reorganizing memories you already have. Dreams exist in a temporary mental space, like messages written in disappearing ink that fade even as you try to read them. This isn't a flaw in your brain's design. It's a carefully orchestrated feature of how your sleeping mind protects you from confusion and mental clutter. Your hippocampus fundamentally shifts its role during different sleep stages. When you're awake, this seahorse-shaped structure deep in your brain actively encodes new memories, carefully filing away experiences from where you parked your car to what your friend said at lunch. During REM sleep, however, this same structure operates completely differently. Instead of creating new memories, it replays and reorganizes memories you already have. Dreams may be the conscious experience your mind creates, while this deeper reorganization work happens. You're experiencing vivid scenarios, but your hippocampus is busy connecting old memories in new ways rather than recording the dreams themselves. The machinery is pointed in a different direction than memory formation. Waking up directly from or immediately after REM sleep dramatically improves your chances of remembering dreams, creating a brief window where dream memories can transfer from temporary storage into something more lasting. Research from sleep laboratories has consistently found that people who naturally wake up more frequently during the night even just for a few seconds, remember significantly more dreams than those who sleep deeply without interruption. This happens because memories require a brief moment of conscious processing to transfer from short-term to long-term storage. When you wake directly from a dream, you catch it while it's still active in your working memory, like a program running in the background of a computer. If you remain asleep, that program closes without saving. But if you wake up, even briefly, you create an opportunity to acknowledge the dream's presence. And that acknowledgement acts like pressing a save button. Specific neurons in your hypothalamus actively promote forgetting during REM sleep, essentially working as dream erasers that clear your mind for the next day. In 2019, researchers published findings in the journal Science about specialized neurons called MCH neurons, melanin concentrating hormone neurons, located in the hypothalamus. These neurons send connections directly to the hippocampus and appear to actively suppress memory formation during sleep. When scientists activated these MCH neurons in mice, the animals performed worse on memory tasks. When they silenced these neurons during REM sleep, memory actually improved. This suggests that your brain doesn't just passively fail to remember dreams. Instead, specific neural populations actively work to clear dream content, making room for memories that serve your waking life more directly. This forgetting mechanism appears to be an evolved feature, not a bug. Acetylcholine plays a surprising and paradoxical double role in your sleep and memory, acting as both memory maker and memory reorganizer depending on your brain state. This neurotransmitter is absolutely essential for memory formation when you're awake. People with Alzheimer's disease, which involves progressive damage to cholinergic systems in the brain, experience devastating memory problems partly because they can't maintain proper acetylcholine function. During your waking hours, acetylcholine helps your hippocampus encode new experiences, marking them as important and worth keeping. But during slow-wave sleep, the deepest stage of sleep, acetylcholine levels drop to their lowest point of the entire 24-hour cycle. This dramatic drop is actually necessary for memory consolidation. Your brain uses this low acetylcholine period to transfer memories from temporary storage in your hippocampus to more permanent storage in your cortex. Then something remarkable happens during REM sleep. Acetylcholine surges back up to near waking levels. But instead of encoding new memories, like it does when you're awake, this REM sleep acetylcholine helps integrate and reorganize existing memories. Dreams occur during this high acetylcholine REM state, which creates a strange situation. The neurochemical environment feels similar to waking, which is why dreams feel so vivid and real. But the neural machinery that would normally capture these experiences and store them for later recall simply isn't engaged in the same way. You experience something that feels real and important, but the biological mechanisms to remember it are temporarily redirected toward other essential work. Your prefrontal cortex, the region responsible for logical thinking and self-awareness, largely shuts down during REM sleep, removing the mental editor that normally decides what's worth remembering. This region at the very front of your brain is crucial for executive functions, planning, decision-making, reality testing, and critically evaluating your experiences. When you're awake, your prefrontal cortex acts like a skeptical journalist, constantly questioning what you perceive and deciding what deserves to be filed away in long-term memory. During REM sleep, activity in this region decreases dramatically, sometimes dropping to levels even lower than during deep sleep. This deactivation explains why dreams can be so bizarre and illogical without triggering any alarm bells in your mind. You might fly through the air, talk to people who died years ago, or watch impossible events unfold. And in the dream, it all seems perfectly reasonable. Your internal critic has temporarily clocked out. But this deactivation also profoundly affects memory. Without your prefrontal cortex's input, your brain lacks the evaluative framework that normally helps flag experiences as important or memorable. Dreams wash over you without the critical analysis that might label them as significant. They're experienced, but not judged. And without that judgment, your brain has no reason to prioritize encoding them into lasting memory. Dream content typically fades in a specific pattern, with emotional cores lingering longer than narrative details, leaving you with feelings whose origins you can't quite recall. Research from multiple sleep laboratories over the past 2 years consistently shows that you don't lose all parts of a dream equally or at the same rate. You might wake up knowing you had an anxiety dream without being able to remember what you were anxious about. Or you might retain a sense of joy or deep peace without recalling any of the dream's actual events or storyline. This happens because different brain systems process different aspects of your experience, and they're not all equally affected by the memory suppression that occurs during REM sleep. Your amygdala, the almond-shaped structure that handles emotional processing, remains highly active during REM sleep, sometimes even more active than when you're awake. The emotional charge of a dream gets stamped more firmly into your neural networks than the narrative details. Meanwhile, the specific images, conversations, and sequences of events depend more heavily on your hippocampus and cortex for proper encoding. And these regions aren't optimally configured for memory formation during dreams. The feeling outlasts the story because different neural pathways preserve them. You wake up carrying the emotional truth of the dream even after its plot has dissolved. Some people naturally remember dreams far more frequently than others. And research published in 2025 revealed that these differences are literally built into brain structure. A comprehensive study analyzing MRI scans from 258 individuals found distinct structural differences between high and low dream recallers. People who remember many dreams showed increased white matter integrity in specific brain regions. The orbitofrontal cortex, parahippocampal gyrus, superior, parietal lobal, and occipital cortex. White matter consists of bundled nerve fibers, your brain's information highways that connect different regions and allow them to communicate efficiently. Better developed connections in these areas appear to support more efficient dream capture and retention. The orbitofrontal cortex, in particular, is involved in processing sensory information and maintaining awareness during altered states of consciousness. Some people's brains are essentially better equipped from birth to bridge the gap between sleeping and waking consciousness, like having a more sensitive recording device that can capture fainter signals. This isn't something you consciously choose or can easily change through willpower alone. It's partly built into how your individual brain is architecturally wired. Norepinephrine, a neurotransmitter associated with alertness and attention, disappears almost completely during REM sleep, removing the chemical signal that normally tells your brain something is important enough to remember. This neurotransmitter helps you focus and pay attention when you're awake. It's part of your arousal system, keeping you alert to important information in your environment. Norepinephrine also plays a crucial role in memory consolidation, essentially acting as a chemical highlighter that marks experiences as worth keeping. During non-REM sleep, norepinephrine levels are low but still present, maintaining some baseline function. During REM sleep, however, these levels drop to nearly zero, creating an almost complete absence of this crucial memory signal. Without norepinephrine, your sleeping brain lacks the biochemical instruction that normally says this is important. Pay attention. Remember this. Even intense or vivid dream experiences don't trigger the consolidation mechanisms that would normally preserve them in long-term memory. It's like experiencing a significant event while the recording equipment is switched off. Dreams may serve a function specifically related to forgetting unnecessary information, acting as your brain's overnight cleaning crew that clears mental clutter. Francis Crick, who won the Nobel Prize for co-discovering DNA's structure, proposed an intriguing theory with his colleague Graham Mitchison in the 1980s. And recent research has revisited this idea with new appreciation. They suggested that we dream specifically in order to forget, that dreams help eliminate spurious memories and unwanted neural connections formed during waking life. Your brain generates millions of random neural connections each day, fleeting associations between ideas, stray thoughts, tangential links that briefly fire together. If you kept every single association, every random thought, every meaningless connection, your mental life would become increasingly cluttered and confused. Dreams, in this view, act like overnight maintenance workers who activate random patterns during sleep. And the patterns that aren't useful or meaningful fail to be reinforced and gradually fade away. The fact that you don't remember most dreams becomes essential to this process rather than a failure. If you remembered every dream with perfect clarity, you'd be cluttering your memory with the very mental noise the dreaming process was designed to clear away. Forgetting dreams might not be an unfortunate side effect, but the entire point. The transition from sleep to wakefulness involves a sudden neurochemical flood that may wash away dream memories, like waves erasing messages written in sand. When you wake up, multiple neurotransmitter systems activate almost simultaneously in a coordinated surge. Norepinephrine returns from near zero to active levels. Acetylcholine shifts from its REM sleep pattern into its waking configuration. Dopamine and serotonin levels adjust. Your prefrontal cortex powers back up. This cascade of neurochemical changes creates a completely different brain state within just a few seconds. Memories are fundamentally state-dependent, meaning you remember things best when you're in a similar physiological and mental state to when you formed them. A dream formed in the unique neurochemical environment of REM sleep exists in a very particular brain state. When your brain suddenly shifts to the radically different waking state, the memory becomes difficult to access. Research on sleep and emotional memory has found that dreaming plays an active role in processing feelings and experiences. Studies show that people who dream after exposure to emotional material demonstrate improved emotional regulation compared to those deprived of REM sleep. The fascinating part is that this emotional benefit comes from processing the feelings while simultaneously weakening memory of specific events. Dreams allow you to work through difficult emotions, update your emotional responses, and integrate challenging experiences, all while the specific dream scenarios themselves fade away. This suggests that forgetting dream content while retaining emotional learning might be therapeutically valuable, protecting you from being overwhelmed by the processing work itself. Sleep stage timing profoundly affects dream content and memorability, with your brain's architecture across the night determining which dreams you might remember. REM sleep occurs in cycles throughout the night, roughly every 90 minutes. But each REM period is different. Early night REM periods are typically short, lasting maybe 5 to 10 minutes, sandwiched between longer periods of deep, slow-wave sleep. Late-night REM periods, especially in the hours just before your natural wake time, can stretch to 30 minutes or even longer. Dreams from these longer, late-night REM periods tend to be more elaborate, more bizarre, more emotionally intense, and sometimes more memorable. This happens partly because there's simply more time for complex narratives to develop and evolve. Longer REM periods also increase the chances of brief, spontaneous awakenings that might help you catch the dream before it fades. Your brain's default mode network behaves completely differently during dreams than during waking rest, creating altered patterns that may contribute to why dreams feel personally relevant yet also strange and disconnected. This network of brain regions typically activates when you're at rest but awake, when you're daydreaming, thinking about yourself, or contemplating other people's mental states. It's involved in self-referential thinking, autobiographical memory, and constructing your sense of identity. During REM sleep, this default mode network shows profoundly altered patterns of connectivity. Some connections strengthen significantly, while others weaken or disappear entirely. This reorganization may contribute to why dreams feel deeply personal and meaningful, drawing on your memories and concerns, yet also feel strange and removed from your normal sense of self. Young children remember dreams differently than adults, with dream recall ability developing slowly alongside other cognitive capacities over years of childhood. Infants and toddlers spend a much larger proportion of their sleep time in REM sleep than adults do, sometimes 50% or more of total sleep time, which strongly suggests they're having frequent dreams. But they can't report them. And even as language develops and children become able to describe their dreams, the reports are typically shorter, less elaborate, and less detailed than adult dream reports. Dream recall ability appears to develop gradually throughout childhood, maturing alongside memory systems, language abilities, and metacognitive awareness. Your hippocampus doesn't reach full adult functionality until several years after birth, and other memory-related structures continue developing well into adolescence. Stress hormones affect dream recall in surprisingly complex ways, with your body's stress response both helping and hindering dream memory depending on timing and intensity. Cortisol, your body's primary stress hormone, follows a natural daily rhythm, typically rising sharply in the early morning hours just before you wake up. Higher cortisol levels can enhance certain types of memory formation, particularly memories with emotional content. But cortisol may interfere specifically with dream recall through several mechanisms. People experiencing high stress often report either dramatically increased dream recall, especially of nightmares, or dramatically decreased recall of any dreams at all. This seemingly contradictory relationship reflects stress's complex effects on sleep and memory. Acute stress may wake you more frequently from REM sleep, providing more opportunities to catch dreams before they fade. Chronic stress, however, often disrupt sleep architecture in ways that fragment REM periods and alter the neurochemical environment. The phenomenon of lucid dreaming offers unique insights into dream memory, revealing what happens when consciousness partially awakens inside the dream state. Lucid dreams occur when you become aware that you're dreaming while still asleep, achieving a hybrid state where you're conscious enough to recognize the dream, but not so awake that the dream collapses. Research analyzing brain activity during lucid dreams has identified distinct patterns that differ from both regular dreams and waking consciousness. Studies using EEG data from multiple laboratories show increased beta band activity in the right temporal and parietal regions, including the temporoparietal junction, areas associated with self-awareness. Lucid dreamers also show enhanced gamma connectivity, particularly in the precuneus, a region involved in self-referential thinking. What's particularly relevant for understanding dream memory is that lucid dreamers consistently report better recall, not just of lucid dreams, but sometimes of regular dreams as well. When awareness partially awakens within the dream state, it appears to engage memory systems more effectively than unconscious dreaming does. Sleep deprivation creates a paradoxical situation where overall memory deteriorates, but dream recall sometimes increases dramatically. When you're severely sleep deprived, your cognitive functions decline across the board, including your ability to form new memories and recall existing ones. Yet dream recall often surges during the first REM-rich sleep period after extended wakefulness. This happens because your body enters what researchers call REM rebound, generating especially long and intense REM periods to compensate for lost REM sleep during the deprivation period. These extended, intensified REM periods produce more elaborate dreams, and the increased intensity combined with heightened patterns of cortical activation can make them more likely to be recalled upon waking. Additionally, sleep-deprived people tend to wake more frequently from lighter sleep stages. Their sleep architecture is fragmented and unstable, which provides more opportunities to catch dreams during brief awakenings. Your brain's visual cortex activates with remarkable intensity during REM dreams, producing vivid imagery without any actual input from your eyes. Neuroimaging studies using fMRI and PET scans show that visual areas at the back of your brain, in the occipital lobe, light up during REM sleep almost as brightly as when you're awake and actually seeing the world. This explains why dreams are so intensely visual, filled with colors, scenes, faces, and movements that feel as real as waking perception. You're not receiving any visual input from your eyes, which are closed and covered by your eyelids, yet you experience elaborate visual content. Your brain generates this rich imagery entirely internally, creating a complete visual world from memory and imagination. However, this intense visual activation doesn't automatically translate into visual memory. Temperature affects sleep quality in ways that indirectly but significantly influence dream recall through its effects on sleep architecture. Your body's core temperature naturally drops during sleep, declining by about 1 to 2 degrees Fahrenheit. And this temperature decrease is actually necessary for deep, restorative sleep. If your sleeping environment is too warm, too cold, or fluctuates significantly during the night, it can cause brief microarousals or keep you in lighter stages of sleep. These microarousals, which you might not even consciously remember, increase the chances of waking from or very near REM sleep, which means more opportunities to catch dreams before they dissolve. People who sleep in well-regulated, comfortably cool environments, typically around 65 to 68 degrees Fahrenheit, tend to sleep more deeply and continuously through the night. Alcohol consumption severely impairs dream recall through multiple mechanisms, even though it might produce unusually vivid or disturbing dreams during rebound periods. While alcohol can help people fall asleep faster initially, it fundamentally disrupts the normal architecture of sleep throughout the night. Alcohol powerfully suppresses REM sleep during the first half of the night, sometimes eliminating it almost entirely during the initial sleep cycles. Later, as your body metabolizes the alcohol and its sedating effects wear off, REM sleep rebounds with unusual intensity, sometimes producing extremely vivid and bizarre dreams. However, alcohol simultaneously fragments overall sleep quality and significantly impairs your hippocampus's function, even when REM sleep does occur during these rebound periods. The memory encoding systems work much less effectively under alcohol's lingering influence. Certain medications can dramatically alter both dream recall and dream content by affecting the neurotransmitter systems involved in sleep and memory. Antidepressants, particularly SSRIs, like fluoxetine and sertraline, often increase dream vividness and recall significantly. Many users report extremely vivid, sometimes bizarrely detailed, or emotionally intense dreams that they remember clearly. This likely happens because these medications affect serotonin systems that play important roles in regulating sleep architecture and the transitions between sleep stages. Conversely, medications that block acetylcholine, including some antihistamines like diphenhydramine or drugs used to treat Parkinson's disease, can reduce REM sleep and dramatically diminish dream recall. Beta blockers, commonly prescribed for high blood pressure and anxiety, affect norepinephrine systems and can also influence dreaming patterns. International collaborations in dream research are creating comprehensive databases that centralize brain recordings and dream reports from hundreds of participants across multiple institutions. These collaborative efforts help answer fundamental questions that have puzzled researchers for decades. Why do some people remember dreams frequently, while others rarely recall any content? Why are we sometimes aware during sleep, while other times we have no consciousness whatsoever? By pooling standardized data from many laboratories, researchers can identify patterns that would be invisible in smaller studies. This large-scale approach represents an important shift in sleep science, moving from isolated small studies toward coordinated international efforts that can reveal universal principles of dreaming and memory. Dream content often incorporates fragments of recent experiences, but transforms them in strange and unpredictable ways that make the dreams harder to remember. This phenomenon, called the day residue effect, shows that elements from your recent waking life regularly appear in dreams, but rarely in direct or recognizable form. Instead, your sleeping brain seems to remix these elements in unexpected combinations. You might dream about a person you glimpsed briefly on the train, combined with a location from your childhood, engaged in an activity related to yesterday's work project, all woven into a narrative that never actually happened. These bizarre combinations may represent your brain's attempt to find unexpected connections between new experiences and existing memory networks. However, this transformational process creates significant problems for later recall. Practice and intention can genuinely improve dream recall over time, demonstrating that this ability involves skills that can be developed. People who keep dream journals, writing down whatever they remember each morning, often develop progressively better recall over weeks and months. This improvement happens through several interconnected mechanisms. The physical act of writing dreams down reinforces neural pathways associated with dream memory, essentially training your brain to pay more attention to these experiences. Setting a clear intention before sleep, mentally telling yourself, "I will remember my dreams tonight," activates metacognitive systems that may remain partially engaged during sleep, creating a kind of background alertness to dream content. People who consistently value their dreams and think about them frequently develop more sophisticated mental frameworks for categorizing and storing dream experiences. Let's pause here and notice your body. As you breathe out slowly, appreciate each tiny cell inside. Trillions of organisms working in silence. Heart beating, lungs breathing, brain dreaming, all without your command. Notice the gentle sensations on your skin, in your muscles, along your spine. You are a complete ecosystem, diverse, self-balancing. Your brain processes thousands of dreams across a lifetime. Most fade, but their work remains. Organizing memories, processing emotions, clearing mental clutter. Trust this. Your mind knows what to keep and what to let go. Now we continue. Natural awakening. When your body transitions gently on its own, respects your sleep cycles in ways alarm clocks cannot. Alarms often jar you from whatever stage you're in, frequently from deep sleep where no dreams occur or remain accessible. Some sleep tracking devices now attempt to wake you during lighter stages by monitoring movement and heart rate. These gentler approaches may preserve dream fragments that harsh alarms would erase. The violence or softness of your return to consciousness shapes what survives the transition. A sudden awakening floods your system with stress hormones that can override fragile dream memories completely. Dreams that occur early in the night differ systematically from dreams near morning in both content and memorability. Early night REM periods, which tend to be short and occur between longer blocks of deep, slow-wave sleep, typically produce dreams that incorporate more immediate, recent experiences and are often shorter and less emotionally intense. Late-night REM periods, occurring after your brain has completed several cycles of deep memory consolidation work, tend to generate longer, more bizarre, more emotionally rich and complex dreams. This pattern reflects your brain's progressive work throughout the night. Early sleep is dominated by slow-wave sleep, when your brain is primarily engaged in consolidating and organizing memories from the day. The language and cultural frameworks you use to think about dreams significantly influence how well you remember them. Cultures around the world vary enormously in how much importance they place on dreams and how elaborately people discuss and share them. Some cultures have rich, detailed vocabularies for different types of dreams, dream elements, and dream experiences, treating dreams as important sources of meaning and guidance. Other cultures tend to dismiss dreams as meaningless mental noise that happens during sleep and isn't worth discussing or remembering. These cultural differences measurably affect dream recall frequency and detail. People from cultures that value dreams highly report remembering significantly more dreams. And when they do report them, Their descriptions are more elaborate and specific. Blind individuals dream differently than sighted people, and studying their dream recall patterns reveals important insights about what makes dreams memorable. People who lost their sight after approximately age 5 or 6 typically continue to have visual dreams throughout their lives, pulling imagery from their stored visual memories formed before vision loss. Those born blind or who lost sight very early in life report dreams completely lacking visual content, but rich in sounds, touch sensations, smells, tastes, and emotional experiences. Interestingly, blind individuals report similar overall rates of dream recall compared to sighted people, remembering roughly the same proportion of their dreams despite the complete absence of visual imagery. The role of slow-wave sleep in dream forgetting is indirect, but profoundly important to understanding the full picture of why dreams fade. During slow-wave sleep, the deepest stage that occurs primarily in the first half of the night, your brain displays large, synchronized waves of neural activity visible on EEG recordings. This is when your body performs much of its physical repair and restoration work. Acetylcholine drops to its lowest levels of the entire sleep cycle, and this dramatic reduction is actually crucial for transferring memories from temporary storage in your hippocampus to more permanent storage throughout your cortex. Slow-wave sleep typically isn't when you experience your most vivid dreams. Those occur primarily during REM sleep. Recurring dreams are often remembered more clearly than one-time dreams, and several interconnected factors explain this enhanced memorability. Some people experience the same dream, or recognizable variations on a central theme, repeatedly over months, years, or even decades. These recurring dreams are typically remembered far more clearly and in greater detail than single occurrence dreams. First, simple repetition strengthens memory through a process called memory consolidation through rehearsal. Each time the dream recurs, it's like practicing the same material, which naturally leads to better encoding and more durable storage. Second, recurring dreams often reflect ongoing psychological concerns, unresolved emotional issues, or persistent life situations, giving them emotional weight and personal significance that aids memory formation even during sleep. Pregnancy and hormonal changes can dramatically affect both dream content and dream recall through multiple biological mechanisms. Pregnant individuals very commonly report increased dream vividness and significantly better recall, especially during the third trimester. This enhancement may relate to several intersecting factors. Pregnancy causes frequent nighttime awakenings due to physical discomfort, the need to urinate, fetal movement, and other physiological changes, providing many more opportunities to wake from or near REM sleep and catch dreams before they dissolve. Major hormonal changes affect neurotransmitter systems involved in both sleep architecture and memory formation. Progesterone, which rises dramatically during pregnancy, has significant effects on sleep patterns and brain function. The brainstem's role in generating REM sleep affects dream memory indirectly, but importantly, a specific region called the pons, located at the base of your brain, where it connects to your spinal cord, initiates REM sleep by sending precise signals that accomplish two crucial things: suppressing muscle tone to prevent you from physically acting out dreams, and activating your cortex in the characteristic pattern of REM sleep. Damage to specific tiny areas of the brainstem can completely eliminate REM sleep, which also eliminates most vivid dreaming entirely. But even with a perfectly intact, healthy brainstem, the neural signals that generate REM sleep don't include any specific biological instructions to remember the resulting conscious experiences. Déjà rêvé. The uncanny feeling of having already dreamed a current waking experience suggests that hidden dream memories may persist below conscious awareness. Some people occasionally experience this distinct phenomenon, separate from ordinary déjà vu. Déjà vu is the feeling that you've lived through the exact current moment before. Déjà rêvé is the specific sensation that a current waking experience was previously encountered in a dream, that you somehow dreamed this moment before it happened. The phenomenon is genuinely puzzling because people experiencing it usually cannot actually recall the specific dream that supposedly predicted the current experience. One intriguing explanation is that you actually do store far more dream content than you can consciously access through normal recall processes. Narcolepsy, a neurological disorder involving severely dysregulated REM sleep, offers unique insights into the relationship between sleep, state boundaries, and dream memory. People with narcolepsy may enter REM sleep directly from full wakefulness, completely skipping the normal gradual progression through lighter sleep stages. They often report vivid, bizarre, hypnagogic hallucination, essentially waking dreams, as they fall asleep. Many individuals with narcolepsy have unusually excellent dream recall, possibly because their REM periods intrude into or occur much closer to waking consciousness, and they frequently wake directly from intense REM episodes. The disorder essentially blurs the normally sharp boundary between waking and dreaming states, and in blurring that boundary, it makes dreams far more memorable. Dream content can be influenced by external stimuli during sleep, yet these stimulus-influenced dreams aren't usually remembered any better than purely spontaneous dreams. Research clearly shows that sounds, lights, physical touch, temperature changes, or even smells can sometimes be incorporated into ongoing dreams without actually waking the sleeper. A ringing phone might transform into a doorbell in your dream. A cold breeze might become swimming in icy water. Your sleeping brain is remarkably creative at weaving external sensory information into its internal narrative. But despite this direct connection between external reality and dream content, these stimulus-influenced dreams typically aren't remembered better than purely internally generated dreams. The practice of dream incubation, deliberately attempting to cultivate specific dream content before sleep, sometimes modestly improves recall of the resulting dreams. Some people practice choosing what they'll dream about, using techniques like visualization before sleep, or repeatedly thinking about a problem they want to solve, or a person they hope to encounter in their dreams. Research shows this mental preparation can genuinely influence dream content. People who successfully incubate specific dream themes often report remembering those dreams somewhat better than their typical baseline recall. This enhanced memory may happen because the pre-sleep mental preparation and intention setting primes memory systems to be slightly more alert to dream content that matches the intended theme. Sleep paralysis episodes are remembered with vivid, often disturbing clarity, revealing what's fundamentally different about them compared to regular dreams. Sleep paralysis occurs when you wake up before the muscle suppression of REM sleep has fully ended. You're consciously awake, your mind fully alert, but temporarily completely unable to move your body. These episodes are frequently terrifying. often accompanied by hallucinatory experiences like sensing a threatening presence in the room, feeling pressure on your chest, or perceiving shadowy figures. Unlike regular dreams, sleep paralysis episodes are remembered with remarkable clarity and abundant detail, sometimes for years or even decades. This happens because during sleep paralysis, you're genuinely awake in the usual sense of the word. The sleeping brain's sense of time differs profoundly from waking time perception, and this temporal distortion creates significant problems for dream memory. Time perception in dreams is notoriously unreliable and fluid. A dream that subjectively seems to span hours or even days might occupy only 5 or 10 minutes of actual REM sleep. Conversely, a brief instant in a dream might feel extended and drawn out, each moment stretching impossibly. This temporal distortion creates fundamental problems for how memories form and are later retrieved. Waking memory relies heavily on temporal context, your ability to place events in time, knowing roughly when something happened and in what sequence events unfolded. Technology is beginning to allow researchers to decode dream content from brain activity patterns, though accuracy remains limited. In several studies over the past decade, scientists have used machine learning algorithms to predict what category of content someone was dreaming about based on their brain activity patterns recorded with fMRI. This requires repeatedly waking participants and asking what they were just dreaming, then correlating their reports with brain scan data. While success is still modest and requires many trials, the research demonstrates that dream content does leave detectable patterns in neural activity. These patterns exist whether or not you consciously remember the dream, raising fascinating questions about how much dream information your brain retains in forms you cannot consciously access. If you're still here with me, thoughts still flickering like candlelight, just notice. Don't judge. Just notice where your mind is. We're exploring consciousness itself, the very thing doing the exploring right now. Strange, beautiful, and perfectly calm. Let's drift onward together. The evolutionary purpose of dreaming remains actively debated among researchers, which profoundly affects how we should think about dream forgetting. Some evolutionary theorists argue that dreams helped our ancestors rehearse and practice responses to threats in a safe, simulated environment, essentially training for dangers without actual risk. Other researchers suggest dreams are merely random neural noise, accidental byproducts of brain activity with no specific adaptive function. Still others propose that dreams exist specifically to integrate new memories with old ones, process difficult emotions, or consolidate learning. If dreams evolved to serve a specific adaptive purpose, that purpose might not require conscious memory of the dream content. Musical dreams can be particularly vivid, rich, and emotionally moving, yet they still typically fade just as quickly as any other dream. Some people, especially musicians and music lovers, dream of hearing music, sometimes familiar pieces they know well, sometimes completely original compositions their sleeping mind has somehow created. Musicians report these auditory dreams significantly more frequently than non-musicians. The auditory cortex genuinely activates during these dreams, processing the musical experience almost as if the person were actually listening to real music. The experience can feel absolutely as real and moving as listening to a live performance. Yet even these distinctive, emotionally powerful Aesthetically rich dreams usually fade rapidly and completely upon waking. Nightmares tend to linger in memory more easily than gentle dreams. This happens for reasons worth understanding. Your amygdala, the almond-shaped brain structure that processes fear, threat, and other intense emotions, remains highly active during REM sleep, sometimes even more active than during waking. Nightmares activate the amygdala with particular intensity, and they frequently cause partial or full awakening, either during the nightmare itself or immediately after it ends. This combination of strong emotional activation and awakening makes nightmares far more likely to be encoded into lasting memory than neutral or pleasant dreams. Additionally, nightmares may have had genuine survival relevance for our evolutionary ancestors. Dreams decay rapidly in memory with each passing minute after waking. Ask someone immediately after REM sleep, and they'll provide rich, detailed narratives. Wait 5 minutes and the report becomes noticeably shorter. 15 minutes later, large sections have vanished. By an hour, only fragments or nothing remains. This steep decay curve suggests dreams never fully enter the stable long-term memory systems that preserve waking experiences. They linger briefly in temporary storage, and unless you actively maintain them through writing or telling, they simply dissolve like footprints washed away by incoming tide. False awakenings, where you dream that you've woken up and begun your day, only to actually wake later and realize the first awakening was part of the dream, reveal fascinating complexities about consciousness and memory during sleep. These experiences can be remarkably disorienting and are often remembered with unusual clarity, perhaps precisely because they mimic waking consciousness so closely. During a false awakening, your brain briefly engages some of the same neural patterns and activation levels it normally uses in actual waking, creating an experience that feels convincingly real. You might dream of getting out of bed, brushing your teeth, getting dressed, even having conversations, all while still completely asleep. Some people genuinely believe they never dream at all. Yet research unequivocally shows this is almost certainly not true for anyone with a normal functioning brain. Laboratory studies consistently confirm that everyone with typical brain development enters REM sleep multiple times per night. And when these supposed non-dreamers are awakened directly from REM sleep in controlled settings, they can usually report dream content, sometimes quite detailed. What these individuals actually mean is that they never spontaneously remember dreams upon waking naturally. This extreme degree of forgetting might relate to how deeply and continuously they sleep, how efficiently their brain maintains the separation between sleeping and waking states, how abruptly they transition between states, or simply how little attention they habitually pay to internal experiences like dreams. The sense of self can be remarkably strange, fluid, or even absent in dreams. And this instability in self-representation creates significant problems for later memory. In waking life, your sense of being a continuous, unified person, recognizably the same individual from moment to moment and day to day, provides a stable framework that helps organize memory. You remember things that happened to you, to this consistent self. In dreams, however, the sense of self becomes remarkably fluid and unstable. You might be yourself, but somehow younger or older than you actually are. You might have different abilities, different relationships, or different physical characteristics than in waking life. Dream sharing within relationships and families can significantly strengthen dream memory through social reinforcement. When people regularly share their dreams with partners, family members, or close friends, several mutually reinforcing processes occur. The act of verbally reporting and describing a dream immediately after waking reinforces the neural pathways associated with that memory, helping it stick more firmly through the process of memory consolidation. Social interest from others provides genuine motivation to remember dreams in the first place. If you know someone in your life wants to hear about your dreams and will be genuinely interested, you're much more likely to make the effort to pay attention and capture them when you wake up. Certain types of brain injuries can selectively eliminate dreaming entirely or specifically impair dream recall while leaving other functions relatively intact. Damage to specific brain regions, particularly areas where the parietal, temporal, and occipital lobes converge, can cause a condition called Charcot-Wilbrand syndrome, where people stop reporting any dreams at all. When awakened from REM sleep, they describe experiencing nothing, or only vague, formless thoughts, without any of the sensory imagery or narrative qualities that characterize normal dreams. This suggests that generating vivid dream experiences requires intact function in these multimodal association areas, where different types of sensory and cognitive processing come together. Dreams can incorporate highly abstract thoughts and concepts, not just sensory images. And these abstract dreams are particularly difficult to remember. While we typically think of dreams as visual movies playing in our minds, dream content actually includes pure reasoning, problem-solving, conceptual understanding, and non-sensory information. You might dream of suddenly understanding a complex idea, grasping a mathematical relationship, or comprehending something profound about existence, all without any accompanying visual representation or sensory imagery. These abstract, conceptual dreams are especially difficult to remember because they lack the concrete sensory details that usually help anchor memories and provide retrieval cues. We've traveled halfway. Take a gentle breath and notice your body resting here, safe and still. Let each breath remind you, time is yours, flowing uniquely through this moment. While consciousness continues to dream, to forget, to remember, this very second, this breath you're taking now, belongs only to you. Your dreams fade each morning, but this isn't loss. This is your mind refreshing, clearing space for what comes next. Rest here knowing your awareness is unique and perfectly where it needs to be. And we continue drifting. The phenomenon of prospective dreaming, dreams that seem to anticipate or predict future events, suggests that some dream memories do occasionally persist in ways that surprise us. Some people report dreams that appear to have anticipated future events, sometimes with uncanny specificity. While the vast majority of these experiences are almost certainly coincidence, selective memory, or unconscious inference rather than genuine precognition, they do hint at something interesting about dream memory. A dream that later seems to match a real waking experience becomes highly memorable precisely because of the emotional impact and sense of significance created by the apparent match. This creates a powerful selection bias. The default mode network's activity during REM sleep may actually facilitate and promote forgetting rather than remembering. This network of interconnected brain regions is involved in self-referential thought, autobiographical memory, and memory consolidation during waking hours. During REM sleep, it shows dramatically altered patterns of connectivity compared to waking. Some researchers propose that these altered connectivity patterns reflect your brain actively reorganizing memories, finding new connections, and integrating recent experiences with older knowledge. In this ongoing process of reorganization, the specific dream content, the conscious experience you're having, may get discarded as unnecessary once the underlying emotional or cognitive work is complete. The dream itself is the processing, not the final product. Sensory deprivation experiences can intensify dreams and sometimes modestly improve recall through reduced competition for mental resources. People who spend extended time in isolation tanks, silent meditation retreats, or other environments with dramatically reduced sensory stimulation often report more vivid dreams and somewhat better memory of them compared to their baseline. With drastically reduced external stimulation during waking hours, your brain may become more attuned and sensitive to internal experiences, including dreams. Dreams might stand out more sharply and distinctly against a background of reduced waking sensory bombardment. Additionally, people in retreat or isolation settings typically have far fewer competing demands on memory and attention. Children's nightmares and night terrors differ fundamentally in memorability, revealing how memory depends critically on sleep stage. Night terrors occur during deep, slow-wave sleep, not during REM sleep. A child experiencing a night terror appears terrified, may scream or thrash, but is actually deeply asleep throughout the episode. Characteristically, the child has absolutely no memory of the episode in the morning. Parents are often distressed and concerned, but the child wakes with no recollection whatsoever. Nightmares, by contrast, occur during REM sleep and are often remembered, at least partially or fragmentarily, especially if the child wakes up frightened and calls for comfort. Regular meditation practices can significantly influence both dream recall and the frequency of lucid dreaming. People who maintain consistent meditation practices, particularly mindfulness meditation, that emphasizes present moment awareness and observation of mental states, often report notably better dream recall and increased occurrence of lucid dreams compared to non-meditators. Meditation may strengthen metacognitive awareness, the capacity to observe and monitor your own mental states, thoughts, and experiences. This skill, cultivated and refined during waking meditation practice, appears to transfer to some degree into sleep states. A mind trained to notice and observe its own thoughts and mental processes during waking may become better at noticing when it's dreaming. Color perception in dreams varies considerably between individuals, and exploring this variation reveals that sensory qualities alone don't determine memorability. Some people consistently dream in vivid, saturated colors. Others report dreams in muted, washed-out tones. A small percentage of people report predominantly black and white dreams, though this has become much less common since the widespread shift from black and white to color television and media. Interestingly, research from the mid-20th century shows that people who grew up watching primarily black and white television were significantly more likely to report black and white dreams. Dream content reflects rich cultural and personal symbolism, but analyzing or interpreting dreams doesn't necessarily improve your ability to remember them. Humans across all cultures and throughout history have sought meaning in dreams, developing elaborate interpretation systems and symbolic frameworks. Ancient civilizations created detailed dream dictionaries. Modern psychology explores dreams as potential windows into unconscious processes and unresolved conflicts. However, actively trying to analyze or interpret dreams doesn't reliably help you remember them better, and can sometimes even interfere with pure recall. The analytical process activates different brain systems and cognitive modes than simple, straightforward memory retrieval. The dramatic transition from REM sleep to full waking involves a coordinated neurochemical cascade that may function partly to wipe the mental slate clean. Within just seconds of waking, multiple neurotransmitter systems shift gears almost simultaneously. Norepinephrine surges from near zero to active levels. Acetylcholine shifts from its REM configuration into a completely different waking pattern. Dopamine and serotonin levels adjust. Your prefrontal cortex powers up from its reduced REM activity to full engagement. This massive, rapid cascade creates a fundamentally different brain state within mere moments. This dramatic transition may serve an important protective purpose beyond simply forgetting dreams. Dreams can sometimes continue if you're briefly interrupted and fall back asleep quickly, suggesting they exist as ongoing neural patterns that can be reactivated. If you wake up partway through a dream and manage to fall back asleep within a few minutes, the dream sometimes resumes from where it left off or continues with related content. This phenomenon suggests that the dream exists as an active pattern of neural activity that can persist briefly, even through a short awakening, and then restart when you return to the appropriate sleep stage. However, even when a dream does continue across a brief interruption, overall memory of it typically doesn't improve significantly. Age affects both dream content and recall in complex, multifaceted ways that change across the lifespan. Young adults typically report more vivid dreams and better overall recall compared to elderly adults. This age-related decline in dream vividness and recall may relate to systematic changes in sleep architecture that occur with normal aging. Older adults generally spend less total time in REM sleep compared to younger adults and more time in lighter sleep stages. Their REM periods may be less intense and shorter in duration, potentially producing less vivid or elaborate dreams. Additionally, age-related changes in memory systems broadly affect dream recall, just as they affect other types of memory formation. Hypnagogic and hypnopompic hallucinations straddle the fascinating boundary between full waking and sleeping, and they're often remembered more clearly than regular dreams. Hypnagogic experiences occur during the transition from wakefulness into sleep. In those drowsy moments as you're falling asleep, hypnopompic experiences occur during the reverse transition, as you're waking up. These can include vivid imagery, sounds, voices, physical sensations like falling or floating, or even complex hallucinations. Because they occur during transitional states rather than deep, consolidated sleep, they're often remembered far more clearly than dreams that occur during stable REM sleep. Dreaming about learning and practicing skills can sometimes improve actual waking performance. Yet the dreams themselves are typically forgotten, even when they provide measurable benefits. Studies have shown that people who dream about tasks they're actively learning, like navigating a maze, playing a musical instrument, or mastering a new video game, often perform measurably better after sleep compared to people who don't report such dreams. The dream content appears to reflect memory consolidation actively in progress, your brain rehearsing and integrating the new skill during sleep. However, participants often don't consciously remember the specific dreams where they were practicing these skills. Language and verbal content in dreams can be surprisingly sophisticated and fluent. Yet specific words and conversations usually vanish immediately upon waking. People report having elaborate, complex conversations in dreams, sometimes even speaking in languages they barely know during waking life. The dreaming brain seems remarkably capable of generating fluent speech, comprehending language, and conducting nuanced verbal exchanges. Yet upon waking, the specific words, phrase, and details of dream conversations are almost always completely inaccessible. You might remember that you had a conversation, recall who you were speaking with, perhaps even retain the general topic or emotional tone, but the actual dialogue itself has vanished without a trace. Physical movement during dreams is actively inhibited by brainstem mechanisms, but your brain still generates detailed movement commands that create the subjective experience of motion. During REM sleep, your brainstem actively paralyzes most voluntary muscles through a mechanism called REM atonia, preventing you from physically acting out your dreams and potentially injuring yourself. However, your motor cortex and related movement planning areas continue generating movement commands exactly as they would if you were actually moving while awake. In your dream, you might run, fight, dance, fly, or perform complex athletic feats, and your brain creates the complete subjective experience of those movements even though your body remains still. Reports of shared or collective dreaming, while fascinating and emotionally compelling, almost certainly reflect coincidence, suggestion, and the reconstructive nature of memory rather than any genuine telepathic dream sharing. Occasionally friends, family members, or romantic partners report experiencing strikingly similar dream content on the same night. These reports can feel meaningful and profound to the people involved. However, such occurrences are quite rare, and when examined carefully, the similarities are usually vague and general rather than specific and detailed. More importantly, memory itself is reconstructive rather than being a perfect recording. Animals clearly also dream, and studying their sleep provides insights into the fundamental nature and purpose of dreaming that don't depend on memory or language. Dogs visibly twitch, move their paws, and sometimes vocalize during sleep in ways that strongly suggest they're dreaming. Rats display brain activity patterns during sleep that precisely match the neural firing patterns recorded while they were navigating mazes during waking, suggesting they're essentially replaying and consolidating spatial memories. Many mammals show clear REM sleep with similar characteristics to human REM. Since animals cannot report their subjective experiences or tell us whether they remember their dreams in any meaningful sense, we can't know what, if anything, their dream experiences are like from the inside. Dream diaries and journals can become remarkably detailed archives, yet most entries describe dreams that would have been completely forgotten otherwise. People who maintain consistent dream journals, writing down whatever they remember each morning, often build impressive archives containing hundreds or even thousands of recorded dreams over years of practice. Reading back through old entries months or years later, dedicated dream diarists frequently encounter detailed descriptions of dreams they have absolutely no memory of having. Despite having written comprehensive accounts at the time, this reveals something important. The act of writing down a dream doesn't guarantee long-term retention of that memory in your mind. The intensity of emotion experienced during a dream doesn't always correlate reliably with how well you'll remember it. You might have a dream that feels overwhelmingly intense in the moment, filled with powerful fear, joy, grief, or love, yet wake up and forget it completely within minutes. Conversely, an emotionally neutral or even bland dream might inexplicably stick in your memory for days or weeks. While emotional intensity generally aids memory formation, the relationship isn't absolute or perfectly reliable. Many other factors influence dream recall: the specific sleep stage and depth, the precise timing of awakening, your overall sleep quality, current stress levels, and elements of simple chance and randomness. Lucid dreamers can sometimes perform deliberate experiments within their dreams and successfully remember the results after waking. During lucid dreams, when you know you're dreaming while the dream continues, some skilled practitioners can deliberately perform specific tasks or tests, like trying to read text, examining their hands in detail, or attempting to fly. The 2025 study, analyzing EEG data from multiple laboratories, showed that during lucid dreaming, brain regions associated with metacognition and conscious self-awareness show significantly increased activity compared to regular, non-lucid dreams. Beta and gamma wave activity increases, particularly in regions involved in self-referential processing. Dreams that occur during brief daytime naps are often forgotten even more readily and completely than nighttime dreams. Nap dreams tend to be shorter in duration and occur during lighter, less intense REM periods compared to nighttime sleep. Additionally, the transition from nap to waking is usually quite abrupt, with people typically moving directly from sleep into immediate activity without any gradual awakening period that might allow dream memories to consolidate. There's no gentle buffer zone for memories to stabilize. Furthermore, people generally don't expect or particularly value dreams from naps, treating naps purely as quick rest periods rather than opportunities for meaningful dreaming. The sleeping brain shows activity patterns that precisely mirror waking experiences, replaying memories for consolidation. Researchers can detect when you're reprocessing earlier events by tracking hippocampal firing sequences. This memory work happens whether you experience conscious dreams or not, and whether you remember them or not. The consolidation occurs at an unconscious neural level. The conscious dream you experience may simply be your awareness creating narratives around this deeper processing work, like stories your mind tells while essential maintenance happens beneath the surface of awareness. Certain natural supplements and herbs are frequently claimed to enhance dream recall and vividness, though scientific support remains mixed and inconsistent. Vitamin B6, galantamine, mugwort, and several other substances are commonly mentioned in dream communities and alternative health circles. Some limited studies suggest these substances might affect sleep, architecture, or neurotransmitter systems in ways that could theoretically influence dreaming and recall. However, the evidence remains quite limited, inconsistent across studies, and far from conclusive. What does seem reasonably clear is that virtually any substance that affects brain chemistry or sleep in any way can potentially influence dreams and dream memory. Some dream researchers and evolutionary theorists propose that dreams function as a form of threat simulation, rehearsing responses to dangers in a safe environment. According to this theory, dreams frequently contain threatening or challenging elements: being chased, attacked, failing at important tasks, losing loved ones. Because mentally rehearsing responses to potential threats during sleep might have improved our ancestors' survival when facing actual dangers during waking life. If this evolutionary theory is correct, the dreams themselves wouldn't need to be consciously remembered for the training effect to work and provide adaptive benefits. The relationship between dreams and creativity is genuine and measurable, but it doesn't actually require conscious memory of specific dreams. Many highly creative people throughout history have reported that important ideas, insights, or artistic visions came to them in dreams. But for every such remembered creative breakthrough dream, there might be dozens or hundreds of forgotten dreams that nonetheless influenced creative thinking in subtler ways. Dreams may prime and facilitate creative processes by loosening normal associative patterns, allowing unexpected combinations of ideas, and temporarily suspending the logical constraints that govern waking thought. After experiencing significant trauma, nightmares can become intrusive and disturbingly hard to forget, representing a problematic breakdown in the normal protective mechanism of dream forgetting. In post-traumatic stress disorder, traumatic dreams often replay disturbing events or variations on them with terrible vividness and clarity. These trauma-related nightmares are remembered with painful, intrusive detail, and sufferers sometimes find it difficult to distinguish nightmare memories from actual memories of the traumatic event itself. This represents a failure or breakdown of the normal forgetting mechanism. When the amygdala becomes chronically hyperactive due to trauma and the prefrontal cortex's normal regulatory control becomes weakened, fear-based and threat-related dreams bypass the usual memory barriers and inscribe themselves forcefully in conscious memory. You might be feeling tired now. That's perfectly fine. Breathe slowly. Feel the cycles. Your mind cycles through waking and sleeping, through remembering and forgetting, through dreams and dreamless rest. All are natural. All are necessary. Like your breath. Inhale. Exhale. Inhale. Exhale. A small cycle within the vast universe of consciousness. You don't need to hold on to anything. You don't need to remember everything. Let it all unfold in its perfect order. Like thoughts arising and fading in meditation. Unhurried. Unresisting. Simply existing. We're almost there now. Every person dreams multiple times each night, even those who claim never to remember any dreams. The universality of dreaming across all cultures, all time periods, and all healthy humans strongly suggests it serves crucial biological functions. Yet the near universality of dream forgetting equally suggests that conscious recall simply isn't part of those essential functions. Dreams do their necessary work silently, operating in the background of consciousness like countless other vital brain processes. Your heart beats without your awareness. Your liver processes toxins without your conscious direction. Your immune system fights infections while you sleep. Dreams may belong to this category of essential processes that operate most effectively when conscious attention doesn't interfere. The feeling of having dreamed, even without specific memory of content, may itself carry meaningful information. Some mornings you wake with a clear sense that you dreamed, a certain quality to your inner state. even though no specific content remains accessible. This vague feeling might carry subtle information about the nature of the dreams that occurred, perhaps a sense of whether they were pleasant or disturbing, emotionally intense or neutral, coherent or fragmented. The explicit memory is gone, but something less tangible persists. A mood, an impression, a subtle coloring of your waking consciousness. This suggests that dreams influence you even when you can't remember them consciously. They subtly color and shape your waking emotional state in ways you don't fully recognize. You're changed by what you cannot remember. Forgetting dreams each night allows you to begin each day with a clean mental slate. If you remembered every single dream with perfect clarity, your mind would gradually fill with thousands upon thousands of remembered experiences that never actually happened in physical reality. You might increasingly find it difficult to reliably separate real memories from dream memories, actual experiences from imagined ones. The forgetting creates and maintains a crucial, clear boundary. Waking life is real, grounded in physical reality and shared experience. Dreams are ephemeral, personal, imaginary. This separation protects your grasp on consensus reality. It allows sleep to be truly restorative, a time when your mind can wander freely without lasting consequences. Some philosophers and contemplatives argue that the transience of dreams beautifully reflects the transience of all experience. Nothing truly lasts forever. Thoughts continuously come and go. Emotions rise and fall. Even your body's cells constantly die and are replaced. Dreams simply make this fundamental impermanence more obvious and undeniable. They're so brief, so fragile, so quick to dissolve that they highlight what's ultimately true of all experience: its fleeting nature. By recognizing and accepting that you truly cannot hold on to dreams, perhaps you learn to hold everything in life more lightly, to appreciate and be present with experience without desperately clinging. The dreams you actually do manage to remember might not accurately represent your overall dream life. Perhaps you remember only the most bizarre, the most emotionally intense, or simply the ones that happened to occur at convenient moments near waking. The vast majority of dreams, the ordinary ones, the quiet ones, the unremarkable ones, might slip away unnoticed and unremembered. When you think about your dreams, you're actually thinking about a highly curated, non-representative selection, not the full picture of what occurs during sleep. You're seeing highlights and unusual moments, not the complete, typical collection. Your conscious understanding of your dream life is necessarily incomplete and possibly distorted toward the exceptional. Writing down a dream immediately after waking inevitably changes and transforms your memory of it. The act of translating internal experience into external words fundamentally reshapes that experience. Language is limited, concrete, linear. It cannot fully capture the multisensory, illogical, fluid strangeness of dreams. When you write a dream, you necessarily simplify it, impose artificial linear structure, and make it fit the constraints and conventions of language. Later, when you reread that written account, you may find yourself remembering the written version more clearly than the actual dream. Your dream journal becomes not merely a record, but a transformation, a translation of one form of experience into a completely different form. Newborn infants spend approximately half of their total sleep time in REM, far more than adults who typically spend 20 to 25%. This enormous proportion of REM sleep is thought to support rapid, crucial brain development occurring during early life. The dreaming that presumably occurs during all this infant REM helps organize newly forming neural networks. But infants cannot possibly tell us what they dream, and they almost certainly retain no memory whatsoever of these early experiences. This demonstrates powerfully that dreaming in its most abundant form occurs entirely without memory, without language, without any capacity for later recall. The essential developmental work of dreams happens in darkness and silence. Occasionally, a forgotten dream memory surfaces unexpectedly hours or even days after waking. A particular smell, visual scene, phrase, or melody might suddenly trigger the return of a dream you had completely forgotten. These rare moments of spontaneous recall demonstrate that some dream memories do persist in hidden form, waiting for the right retrieval cue. But such moments are unpredictable and rare. You cannot deliberately search your memory for forgotten dreams. They return only by chance, if at all. This suggests that dream memories exist in a fundamentally different format than normal waking memories, stored in ways not readily accessible to conscious. Voluntary retrieval. People who experience frequent lucid dreams sometimes report feeling noticeably tired during daytime hours, suggesting that increased awareness during sleep may reduce its restorative quality. There may be an unavoidable trade-off between dream awareness and sleep quality. The very neural mechanisms that would help you remember dreams more vividly and maintain consciousness during sleep might interfere with sleep's primary biological purposes: to rest, restoration, and unconscious memory consolidation. Normal dream forgetting might actually be the necessary price for truly restorative sleep. Too much awareness, too much consciousness during sleep, even self-awareness within dreams, may partially defeat sleep's essential purposes. The subjective experience of dreams is ultimately private and fundamentally inexpressible. No one can truly know what another person's dreams are actually like from the inside. Even detailed, elaborate descriptions inevitably fall short. Dreams resist language and description. They exist in a realm beyond and before words, composed of fleeting sensations, impossible perspectives, emotional tones that have no precise names. This inherent ineffability significantly contributes to forgetting. If an experience cannot be adequately encoded in language or other symbolic systems, memory naturally has great difficulty holding on to it. Dreams slip away, partly because we simply lack adequate tools to capture and preserve their strange, non-linguistic nature. Some dream content may genuinely reflect essentially random neural firing with no particular meaning or purpose. Not every dream needs or warrants interpretation. Some dreams might simply be noise, your brain maintaining minimal activity during sleep, generating semi-random patterns without deeper significance. If this is true for at least some dreams, then forgetting meaningless content is simply efficient. Your brain conserves valuable resources by not bothering to remember content that served no useful purpose. Only occasionally might a dream contain something genuinely worth preserving. An insight, a resolution, important emotional processing. And even then, your brain might not recognize it as worth the effort of saving. The border between remembering and forgetting is not sharp but fuzzy and gradual. Some dreams are clearly, vividly remembered. Others are clearly, completely forgotten. But many exist in an uncertain twilight zone between. You might remember that something happened without knowing what. You might retain a single image completely devoid of context. You might preserve an emotion without any accompanying story or explanation. These partial, fragmentary memories show that forgetting isn't a simple all-or-nothing binary process. It's gradual decay, with some elements proving more resistant than others. Emotions tend to outlast facts. Vague impressions outlast specific details. Your mind creates entire elaborate worlds while you sleep. Every night during REM sleep, your brain constructs vivid, detailed experiences from memory fragments, emotions, abstract patterns. Characters appear fully formed. Conversations unfold naturally. Entire landscapes emerge, complete with weather and atmosphere, all generated entirely from within your own neural networks. These dream worlds feel completely real in the moment, experienced with sights, sounds, and sometimes even convincing physical sensations. Yet they vanish upon waking like morning mist burning off in sunlight. The sleeping brain is not simply resting, but actively creating, endlessly exploring possibilities that waking life never offers or allows. We dream about our deepest concerns and most important relationships. Dreams naturally weave together the meaningful threads of our lives. They revisit unresolved situations, process difficult emotions, explore feared scenarios, rehearse desired outcomes, and sometimes offer unexpected new perspectives on old problems. This emotional and personal relevance suggests dreams serve genuinely important psychological functions in processing experience and maintaining mental health. Yet we systematically forget them. The essential work happens regardless of conscious memory. Your psyche processes, integrates, and heals during sleep, and conscious recollection of the process isn't required for benefit. The healing happens in the doing, not in the remembering. Forgetting dreams mirrors larger truths about consciousness and memory that apply beyond sleep. Most of what happens in your brain never reaches conscious awareness. The vast majority of neural processes operate entirely unconsciously. Memory itself is highly selective, preserving only tiny fractions of your total experience. Forgetting is normal, necessary, and constant across all aspects of life. Dreams simply make this obvious. They're rich, detailed experiences that feel vivid and completely real, but leave virtually no trace. They remind us clearly that consciousness is selective and narrow. That awareness captures only a small slice of reality, and that most of what we fundamentally are exists beyond our capacity to know or remember. Perhaps the real question isn't why we forget dreams, but why we remember any dreams at all. Given the neurochemical conditions of REM sleep, the deactivation of memory systems, the absence of key neurotransmitters, and the state-dependent nature of memory, the default expectation should be total, complete forgetting. The fact that any dreams are ever remembered, even fragmentarily, might be the true anomaly requiring explanation. Maybe we remember fragments only when something goes slightly wrong, when we wake at an inopportune moment, when the transition between states is somehow incomplete or disrupted. Normal, optimal, healthy sleep might actually mean complete dream amnesia. Some dream researchers study thoughts that occur during dreamless sleep, finding that even without REM, mental activity continues. Thoughts occur during non-REM sleep, though typically less vivid and less narrative than REM dreams. These non-REM thoughts are forgotten even more completely than dreams. If vivid REM dreams are ephemeral and easily forgotten, dreamless sleep thoughts are like ghosts of ghosts, nearly impossible to capture. Yet they happen continuously. Your mind is never truly blank during sleep. Consciousness exists on a continuum, from vivid dreams to vague thoughts, to something approaching unconsciousness during deepest sleep. And almost all of it dissolves into forgetting. Dreams connect us to something larger than individual existence. Across all time periods and cultures, humans have dreamed. Ancient peoples dreamed. Your distant ancestors dreamed. Future generations will dream. Everyone who has ever lived has experienced this nightly journey into strange inner territories. The specific content varies infinitely, but the universal experience remains. And universally, nearly universally, most of it is forgotten. This shared forgetting is part of the human condition. We all carry experiences we cannot retain, knowledge we cannot keep, visions that dissolve before we can grasp them fully. There's genuine beauty in the forgetting itself. If we remembered everything perfectly, every experience, every thought, every dream, our mental life would become cluttered, overwhelming, perhaps unbearable. The mind needs space, needs emptiness, needs room to breathe. Forgetting creates that essential space. It allows the new to enter, the fresh to emerge. Each night's dreams can be fresh and original because yesterday's dreams have faded. Each morning can begin unencumbered by the strange journeys of the night. The forgetting is not loss but renewal, not absence but openness, not failure but grace. Some dreams perhaps we're genuinely meant to forget, dreams that process trauma, that work through difficult emotions, that integrate painful experiences. Maybe these accomplish their healing work most effectively when we don't consciously remember them. The healing happens beneath awareness. In neural networks we cannot directly observe. Consciousness steps aside and allows deeper processes to do necessary work. When we wake, we're subtly changed by dreams we don't remember, gently shaped by experiences we never consciously held or knew. Your forgotten dreams aren't truly lost. They shaped your brain as they occurred. Neural connections strengthened, emotions processed, memories reorganized. You carry these effects without conscious memory of the experiences that created them. The forgetting is of the conscious experience, not of the neural work accomplished. You are quietly changed by every dream you've ever had, whether you remember them or not. The dream's work persists even as the dream itself fades. Accepting dream forgetting might be easier and healthier than fighting against it. Trying desperately to remember dreams can create frustration and anxiety about sleep itself. Some people wake themselves repeatedly trying to catch dreams, severely fragmenting their sleep quality. Others stress about forgotten dreams, feeling they've lost something precious and important. But what if the forgetting is exactly as it should be? What if letting dreams go is simply part of their essential nature? Perhaps accepting impermanence in this small realm of dreams teaches valuable lessons about accepting impermanence everywhere in life. The scientific study of dreams continues evolving rapidly. New research tools, innovative methods, fresh insights emerge regularly. The studies from 2025 we've discussed throughout this journey. The Dream Database, Lucid Dreaming Research, Neural Architecture Findings represent the current cutting edge of understanding, but much remains genuinely mysterious. Why dreams exist, what ultimate purpose they serve, and why we systematically forget them are questions still actively debated. Science can describe mechanisms, trace brain activity, measure neurotransmitters with precision, but the subjective experience of dreaming and its deeper meaning remain in realms science hasn't fully reached or explained. Each person's relationship with dreams is unique and valid. Some people treasure the few dreams they remember, finding deep meaning and inspiration in them. Others barely notice dreams at all and don't particularly miss them. Some wish desperately they could remember more. Others feel grateful for the forgetting, especially if their dreams tend toward the disturbing. There's no universally right way to dream or to forget. Your experience is your own, valid and complete. Whether you remember many dreams or very few, whether you seek meaning in them or dismiss them entirely, you're experiencing something fundamentally and universally human. Perhaps dreams ultimately teach us to live fully in the present moment. They arise spontaneously. They unfold mysteriously. They vanish completely. And they cannot be held or preserved. Like everything in life, they're temporary and impermanent. Trying to grasp them tightly only makes them slip away faster, like trying to hold water in clenched fists. The practice of letting dreams go might be profound practice for letting everything go when the time comes. Not with indifference or resignation, but with grace and acceptance. Dreams whisper their gentle lesson again and again. Let go, let go, let go. And in the natural forgetting, perhaps, there's a kind of freedom, a kind of peace. The dreams come, they do their work, and they fade. And that is enough. That is exactly as it should be. And so our quiet journey through the mysteries of dreams and forgetting comes to a gentle close. We've traveled from the hippocampus quietly working during sleep to the MCH neurons that actively erase, discovering along the way that forgetting is not failure, but function. Not loss, but design. From the chemistry of acetylcholine to the brief glow of lucid awareness, we've glimpsed how consciousness dances at the edges of sleep, creating experiences that dissolve like morning dew. Dreams remind us that experience itself is impermanent and fleeting. Much of the mind's deepest work happens in silence, below awareness, in depths we cannot directly observe or measure. Our forgotten dreams teach patience, teach acceptance, teach letting go. Without forgetting, there would be no space for tomorrow's dreams, no room for tomorrow's growth. By releasing what we cannot hold, we remain open to what comes next. And now, in these final minutes, take the deepest breath you can, as deep as possible. Think about consciousness itself, yours, mine, everyone listening, all awareness, everywhere, perhaps all connected in ways we don't yet understand. You are not alone in the universe of minds. Think about how every person who has ever lived has dreamed and forgotten and dreamed again. Across centuries, across cultures, this rhythm continues eternally. Let your entire being dissolve into the ocean of consciousness, into dreamless rest, into the space before thought, into the silence before words. Prepare for deep sleep, No boundaries left. Only peace. Only stillness. Only rest. If this thoughtful exploration of the mind made you feel less alone tonight, whisper it forward to someone still searching in the darkness. It may bring comfort to one more wandering consciousness seeking answers. One quiet share, one peaceful night at a time. But there's no need to do anything now. Nothing at all. You've traveled far tonight, through the neuroscience of forgetting and the poetry of consciousness and the mystery of why we dream. You can allow these thoughts of dreams and memory to fade now, like dreams themselves naturally do, leaving only the gentle calm behind. Only peace, only stillness. Let your breathing deepen naturally. Let your body feel heavier, as if gravity itself is gently pulling you deeper into rest, deeper into sleep, deeper into the darkness that heals. If sleep comes now, let it carry you like a wave, smoothly, inevitably, peacefully, into a realm where time and weight no longer matter, where questions dissolve, where understanding isn't needed. If your eyes are still open, the next video is waiting for you, ready to continue this journey. But if they're closed now, stay there. Stay in the darkness that feels safe and warm and right. Tomorrow, dreams will still be there waiting. Your brain will still create its nightly theater, its mysterious journeys. Memory will still choose carefully what to keep and what to release. But tonight belongs to stillness, to rest, to letting go. Rest well, curious mind. And remember this final truth. Your forgotten dreams are not lost. They've done their work in silence, beneath awareness. You are changed, shaped, healed by what you cannot remember. Fall asleep to gentle facts, where science meets sleep. Dream deeper with bedtime science. Relax, listen, and drift into sleep. Good night.